Now we are going to start the second chapter, that is complex number. What is meant by complex number? Are they similar to real number? That is the question which is arising in our mind. So first of all, we have to clear up what are complex numbers. That will be given in the introduction. If we see up to this study level, we are familiar with whole numbers, natural numbers, integers, positive, negative including 0, rational number and irrational number. They are all the subsets of real number. And also we have learned about how can we solve the linear equation, quadratic equation and biquadratic equation, and getting their solution as natural, integer, rational, irrational, whole numbers. But there is a case that is in quadratic equation, that is ax square plus bx plus c is equal to 0. If we have discriminant d is equal to b square minus 4ac less than 0, that means value of x cannot be a real number because square root of negative is negative number does not exist in real number system. That is under root of minus a does not exist in real number system. So our mathematicians work out on this and they extend the real number system to in such a way that their calculation of algebraic multiplication can be done easily and defined properly. And this new set is nominated as complex number and is made up of real number. So the extension of real number system should be in such a way that the algebraic operation such as addition, multiplication, subtraction, division, can be defined properly in a proper manner. So this new set is called the set of complex numbers and it is denoted by C. So this was the introduction of complex number, how complex number are introduced in mathematical field. When there is no possible solution of square root of negative number in real number system, then they need to be extend the real number system such that all the operations, that is algebraic operation, are defined in a proper way, and this new set formed is called, under such properties, is called complex number, and it is denoted by C. Complex number is formed with the help of real number. So we say that extended real number system in such a way that a new set is defined, that is called complex number. That is, the next topic is the set R cross R, that is a Cartesian product of R cross R, that is ordered pair represented in R cross R as both the elements are real number, and the set of complex number. Or we can say that formation of complex number set under the algebraic operation defined in R cross R. So we are going to start with the set R of real numbers to obtain the set C, that is complex number, so R cross R set of all ordered pair of real number, and R cross R can be written as A comma B element in ordered pair such that A belong to real number and B belong to real number. So with the help of this set we form the complex number set. So now, as we defined above, we shall define algebraic operation under R cross R. That is, we shall define equality, addition, and multiplication of two elements of R cross R. So the first one is, that is equality. Equality means we are stating the condition when two ordered pairs are equal. So, two elements, that is ordered pair AB and CD of R cross R, are defined to be equal if A is equal to C and B is equal to D. That is, if A is equal to C and B is equal to D implies ordered pair AB is equal to ordered pair CD. For example, if we say is 1, 4 order pair is equal to 4, 1, no, this is not possible. 1 is not equal to 4 and 4 is not equal to 1 mathematically. So these are not equal. And if we say sin square x plus cos square x, log 1, this is a 1 order pair which is equal to 1, 0. This is true because sin square plus cos square is always 1. This is identity, and log 1 is equal to 0. So these are the equal ordered pair. So ordered pair are equal if A is equal to C and B is equal to D is fulfilled. Now the second property is, that is addition. Here we will learn how can we add these two ordered pairs. The sum of two elements, that is ordered pair AB and ordered pair CD, is defined as follows. That is, ordered pair A and B and ordered pair C and D is added as first element of both ordered pair, that is A plus C, and then adding second element of both ordered pair, that is B plus C. That gives the sum of two ordered pair. For example, if we have 1, 2 and plus 5, 6, then we will add up 1 plus 5, 2 plus 6. That gives the result, that is 6, 8. This is the method how can we find the addition. Same case is done in the case of subtraction. Now the third property is, that is multiplication. So here we learn how can we find the product of two elements. So product of two elements A, B and C, D of R cross R is defined as follows. That is, A comma B product, that is into C comma D, will give the result first A into C minus B into D, and then A into D plus B into C. So this is the form. How can we find the product of two ordered pairs? For example, ordered pair is 5, 2, product 2, 3. It gives A into C, that is A, B, C and D. These are the ordered pairs. So A into C, 5 into 2 is 10, minus B into D, 2 into 3 is 6, comma A into D, 5 into 3 is 15, plus B into C, that is 2 into 2 is 4. So we get a new ordered pair, that is 4, 90. So this is the way how can we find addition, multiplication and equality of two ordered pairs. These are basic algebraic operation. So the set R cross R with these roots is called the set of complex numbers, and it is denoted by C, that is R cross R is written as A comma B ordered pair where A belongs to R and B belongs to R can be written as Z is equal to A plus iota B. What is meant by iota? As Z is equal to A plus iota B, iota is I, that is under root minus 1. That is a value that make a simple real number pair into a complex number. So when we get negative of this value, if we have negative of minus A, this can be turned out negative in minus into A. So it can be written as under root A iota. So this makes the simple number into complex number, and by this we can find the roots of any equation that will come out in the form of complex number. So if we see here, what are A and B? A is the real part of Z and B, which is introduced with iota, that is called imaginary part of Z. So by R cross R set we can form the complex number, that is Z, and which is right in the form of first element plus iota times second element, that gives a complex number form system.